What is a derivative? Well, it's a slope at a point, and here we have two formulas for it. We'll be using the second one to visualize the derivative. We have a parabola, and as you can see, as the blue dot gets closer to the yellow dot, the height decreases. And we find that the slope at x is equal to 5 is equal to 1.8. And we can find the equation of the tangent line, which is one of the most common questions, and we plug in the point and the slope to get the tangent line there. We can also use the definition to find the derivative. So for that question, let's write down the formula, and then here we need to plug in x plus h and x into our function. And we can simply cancel out the h's right there. And if you can't do this, then you probably did something wrong. And we have to now find the limit. And when you do that, you get 10x minus 1 at the very end. There are three cases when derivatives don't exist: a sharp turn, a discontinuous function, or any vertical tangent. You can find derivatives in other areas, but just not those places. The power rule is very simple. You simply put the exponent as the coefficient and minus the exponent as well. So here are three quick and easy examples for you to review. Now here's the formula for the product rule. We have to find two functions inside, and in this example, it would be 3x cubed and x sine of x. Just apply the derivative and follow the formula. Now, here's the formula for the quotient rule. You almost always use it when there's a fraction as a question. And just like before, you find the derivatives of the numerator and denominator and follow the formula to get your answer. Next, we have trigonometric functions. You're going to have to memorize this list, but we can use our sum and difference derivative rule for this specific question. And the derivative of tan of x is just secant squared x. And then we can just combine those answers together. Here's the chain rule. You can think of it as nested functions. And let's do an example about this. So inside the bracket there, you can visualize that as just u, and we can make a substitution. We can find the derivative of u, and then we can find the derivative of the inside. We can combine all the answers together to get our final result. For implicit differentiation, there's a couple of steps you need to memorize. A classic problem involves y's and x's. We're going to have to differentiate this both sides with respect to x. We need to factor out all the dy's and dx's here. And after we do that, we can solve for dy dx by dividing both sides. And then we get our answer. Related rates can be really tricky, but here's some general steps to go about it. We have a word problem about air being pumped into a balloon, and we know the rate of change in radius. So we always start with the formula. We're going to differentiate that with respect to time. And we know the rate of change in volume and radius because that's what they give us in the problem. So let's plug it in. And then now finally we solve for dr over dt, which is the rate of change there.